we will see the effect of temperature. Effect of temperature on muscle contraction. Okay? So to see the effect, whether there is any effect on muscle contraction, muscle conduction velocity. So first we will take a normal graph at room temperature. Then we will apply some hot ringer, say of 38 degrees centigrade, on the muscle and on the nerve. The muscles and the nerve are fitted on the myograph. I have taken one simple muscle contraction and switched off. Now, after that, I will apply some hot saline, means hot ringer saline, on the muscle and on the nerve, and wait for a few minutes. Okay? For about a minute. And after that, I will again give a stimulus. Now the muscle is hot and the nerve is also hot. So under this condition, again I will take a simple muscle twitch. So see what is happening. What happens to the latent period? What happens to the contraction period? What happens to the relaxation period? If you find any change, then you have to explain why this change has been made. You may get some change on height of contraction, means force is generated. If it is increased, you may interpret as with the increasing temperature, more force is generated. Since the height of contraction is increased. And after that, again we will apply some normal saline, normal ringer, to bring the temperature to the normal temperature, room temperature. Then I will apply a cold ringer, say of 18 degrees centigrade or 16 degrees centigrade. Now let's see what is happening. Whether there is any change in latent period, whether any change in contraction period, relaxation period, and height of contraction, means the force generated. It may be increased or decreased. You see what is happening? Then you have to interpret why it has happened that. We know the enzyme activity increases with temperature up to a limit. Thereafter, what happens? If it is too much, then the enzymes are protein in nature. The protein in nature, the proteins, these enzymes will be denatured. So they will lose their activity. Okay, so it will increase up to certain limit. Thereafter, it will not increase. Rather, it will be, then activity will be lost. Okay? This is one effect on the enzyme. Moreover, if enzyme activity is increased, these enzymes are doing some functions. For example, in muscle, these enzymes are involved in energy generation. If the activity is increased, there will be more production of ATPs. So more ATP will be available for muscle contraction. Now the muscles can contract easily because more energy, ATP are now readily available. Okay. We also know among the properties of the nerve, one factor is temperature. When temperature is increased, the velocity of conduction of nerve impulse is also increased. When you decrease the temperature, the velocity of nerve impulse also decreased. We have also seen the neuromuscular junction. In the neuromuscular, the transmission process, neuromuscular junction, the transmission process is also increased with the increasing temperature. Here also some enzymes are involved. Some proteins that regulate the different channels. So their activity may be increased or decreased. This protein's activity may be increased or decreased. Some ATPase, sodium, potassium, ATPase pump is there. These are enzymes. So its activity can be increased or decreased by temperature. As a result, by increasing or decreasing temperature, we can modify the transmission process across the membrane. Similarly, the contraction process, it also requires various enzymatic reactions. ATPase, myosin ATPase activity has to be increased. So again, this is an enzyme. Moreover, we know the muscles contain some proteins. These proteins are having certain viscosity. If we apply temperature, the viscosity will be increased or decreased? Yes, very good. It will be decreased. The viscosity means viscous, thick. So if muscle viscosity is a resistance to muscle contraction. If viscosity is decreased, then contraction will be easily done. Then easily muscle can be contracted. When we apply cold temperature, viscosity will be increased. So this will increase the viscosity. As a result, what will happen? The contraction will be difficult. Because increased viscosity means increased resistance to muscle contraction. So we have seen temperature causes faster transmission. In hot environment, transmission is faster. In colder environment, slower. Number one. Secondly, the neuromuscular junction, the activity of the neuromuscular junction, is increased with temperature. The junction transmission will be faster when there is increase in temperature. It will be slower when there is decrease in, because most of the activities are regulated by the proteins. Different for proteins are there are enzymes regulating the transmission process. Okay, and there are channels. So all these are made up of only protein only. So their activity can be modified by temperature. Okay, again, the excitation contraction coupling, this can be made faster with increasing temperature, it can be made slower. And the muscle contraction process can also be affected by temperature, because we know the muscles are having some proteins, and these proteins exert some viscosity. So if you increase the temperature, viscosity will be reduced, and viscosity is the resistance to contraction. So muscle can easily, in hot environment, it easily can contract. Moreover, in the muscles, for muscle contraction, energy is needed. So energy comes from some biochemical pathway, biochemical reactions, enzymatic reactions, means glycolytic path, physiological path, they will provide the energy. So since the activity of these enzymes are increased, all these enzymes are increased, then the production of ATP will also be increased. So all this together facilitates contraction process. When the temperature is decreased, it will be decreased. Okay, now let's see what will happen to what we will observe in the curves. So this is the initial condition. It is ready. The muscle is at room temperature and it is having the long arm and it will be writing on the here the chymograph drum. So in this condition, this is in room temperature. So I will give one stimulus to the nerves. So there will be one contraction. So this is simple twitch, simple muscle contraction at room temperature, at normal temperature. Then what I will do, I will apply some hot ringer on it and over the nerves. Now the muscle will be heated, its temperature will be increased, the temperature of the nerves will be increased. Now again you will perform the same experiment. You switch on, so give one stimulus, then again another curve you will get. See what has happened, what changes are there in the second curve. Then again what you do after switching off the chymograph, you apply normal saline. Bring the temperature down to normal. Then you apply the cold saline. Means cold ringer. Then again you apply stimulus. Now there will be a contraction. Okay. So now you got 3 cups. And the point of stimulation is same. At the same point. Every time the point of stimulation is at the same time. Only thing, the contraction, starting of contraction will be different for the 3 cases. Maximum height of contraction, point of maximum height of contraction, that will also differ. And point of relaxation will also differ. Okay? And let's see. So this way, the curves are made, effects are recorded on the chymograph. Now see, what are the changes? The middle one, it is a normal curve. The top one at 38 or 40 degrees centigrade, this is the with hot saline, hot ringer, and this is with cold heat. Now you tell me, what happened to latent period? This is the normal one. So latent period from here to here is the latent period. But this twitch is with hot saline. Now see, latent period is increased or decreased? Latent period is decreased.
Distance is less now. Distance is less now.
Less time. It took less time to contract. It means the impulses travel faster. Impulses, I know this time is required for conduction also. That means less time, latent period is less. So one of the reasons maybe we know theoretically, nerve transmits signal faster in hot environment. So it may be because of that. It may be because of that. See. Now, what about the cold curve? It has increased more than normal. It has taken longer time. Why? Because transmission is slowed down with decrease in temperature. This is the property of the muscle, the property of the nerve. Okay, so very easy observation on latent period. Latent period with normal temperature.
0.02.
So
Between.
this will be the latent period. From here to here. So you draw a vertical line and now you see how many frequencies are there. Okay, so you are starting from here. Okay, from here and ending here. So how many frequencies? One completed
Second half.
and half. More than half. Quarter. That is 1.75. 1.75 number of frequencies 1.75 into 0.01. This is the latent period. Calculate it. So under normal condition. Then with this
Hot temperature.
hot. So how many frequencies are there? Up to this. So 1.25. 1.25 into 0.01. Now with cold temperature, what will be the latent period? 2.5 into 0.01. So this is your observation on latent period. That means in short, what you can say? Temperature, hot temperature decreases latent period,
And cold. Decreasing temperature.
increases latent period. Why?
Because of the nerve impulse travels faster.
Conduction. Because temperature affects conduction of nerve impulse through the nerves. Temperature increases the conduction. That means conduction will be faster, less time will be taken. That's why latent period is less. Okay? And the effect of cold is just opposite. Okay, now see. She will now measure the contraction period. She will now, you measure the contraction period, you dictate them, how many frequencies is there, so they will calculate the time for normal, for 40 degrees centigrade and with 10 degrees centigrade. Twitch with a 40 degrees centigrade ringer and twitch with 10 degrees centigrade, calculate the contraction period. This is maximum point. So this is the contraction period, normal contraction period. And no, normal contraction period is this, from here, isn't it? This is the normal curve. To maximum height is this. So this is the contraction period and this is the relaxation period, isn't it? Is that correct? Okay, now you calculate the how many frequencies are there in the contraction period and how many frequencies are there in relaxation period. Now I will call you. Be ready. Now your turn.
6.7. 6.7.
6 point?
7.
Okay, now you see. She said it is 6.75 contraction period. Contraction period starts from here and ends where? C1. Okay. So I am drawing a vertical line from here. So you can say starts from here. Starting from here, isn't it? Okay. And ending? Here. So how many? 1, 2, 3, 4, 5.5. Not 5.5, 5.25. এই জায়গায় বলে 5.5, এখানে হলো 5.25, এখানে হলো 5.75. Now calculate the time. 5.5 into 0.01. So how much it comes? So this is the contraction period with normal ringer solution. Calculate it. Okay. This is the normal curve. Okay, with normal temperature. So from here it started relaxing. Here end of relaxation. Okay. So maximum contraction is here. So from this point, this is the point. From this point to this is relaxation time. So draw a vertical line here. How will be drawing? Up to this 0.75. 0.5 plus 2.5. Up to from here. See, 1, 2, 3, 4. 4.5 plus 2.5, 4.75. So what is, how many frequencies are there? Relaxation period of normal. Yes. From C1 to D1, right? So how many frequencies are there? D1 is touching here. This is the cross. This line is touching this line, so it should be this line.
1, 2, 3, 4, 4.5, and this half. 5.
Half. Half. So here is half, not half. If you consider it, this is half. This is 0.75. So 4.75 into 0.01. So this will be the latent relaxation period. Okay. So you got latent period, relaxation period, and contraction period. Now let us see what happens to these periods with 40 degrees centigrade ringer solution. Okay, who will calculate? The frequent number of frequencies will count. Let us count from the bottom. Okay, so from here to here, this is 1.25. 1.25 into 0.01. So this is the time latent period for
that latent period of
for 40 degrees centigrade. Okay. Now what is the contraction period with 40 degrees centigrade temperature? 1, 2, 3, 4 plus this much
4.2.
4.25.
Yes, sir.
So you are wrong.
Sir, my
You are now convinced?
Yes, sir.
Okay.
My 4.2.
So 4.25 is the number of frequencies in contraction period. This is the long arm. This is the long arm of the stylus of the lever. So here is a fulcrum. It is the fulcrum. So now if it moves like this, what you will get? An arc or a straight line. Actually, these lines are drawn with the stylus. So after completion of the graph, what is the drum is moved to the center position. Then what is there? This is a stroke, upward stroke is made so that it will make a line. So here is the fulcrum. So it will move like this. It will make an arc. So this will not be the vertical line. This will be. So I am suggesting you to make a vertical line with your pencil. Okay. Then you will be up to the time tracing. Then very easily you will be able to calculate. Is that clear? Doubt gone? How can you determine the rate of contraction? Rate. At what rate the muscle is contracting? How can you determine? For rate, determination of rate, you need what? A time and distance. Rate means what? Per unit of time, how much work is done, or how much distance is traveled, or how much contraction is made. So that is the rate of contraction. How much contraction is made. Okay, so from height, I can determine how much contraction is made, and duration, I know, is a contraction period. So divide these, height, divide the time, then you will get the speed. Rate, speed means here you will get the rate. So this way you can calculate the rate of contraction. So while studying, what you will be first, you will be measuring the three time periods. Three time periods and height of contraction. From height of contraction and contraction period, I can determine rate of contraction. So, in three different situations, we can measure the values of these four values in three different conditions. Okay? And then we compare whether it is increased with temperature, with 40 degrees temperature, whether it has been increased or decreased, that way. You can calculate this also from here. This is the ideal one. This is not the ideal one. Okay? This is the ideal one. Here what happened? The green one is the normal. So this is the latent period and this is the contraction period and this is the relaxation period. See, latent period is decreased here with hot saline. Latent period is increased with cold saline. So this is our observation on latent period. And what is our observation on contraction period? Contraction period is decreased with hot. Contraction period is increased with cold. Relaxation period is decreased with hot. And relaxation period is increased with cold. That is our observation. Okay? Now you have to explain why, sir. Now I have already discussed, explained why this, what is the reason behind, what is the physiological explanation of this increase in or decrease in latent period. What is the cause of increase or decrease in latent period?
Enough conduction. Conduction.
Temperature. With temperature? No. Temperature, velocity of nerve impulse increases. If with cold, it decreases. This is number one. Number two, why contraction period with hot temperature, why contraction period is short? Explanation is, it took less time to travel neuromuscular junction. It took less time for AC coupling. It took less time for contraction because of lowering of viscosity. And it took, the contraction was faster because availability of ATP was more, of ATP was more because of faster enzymatic process within the muscle. Okay, so these are the reasons. And opposite is the effect of cold. And during relaxation, same thing. Inertia is lessened, became reduced with temperature. With cold, it will be increased. Viscosity will be increased, so time will be more. Okay, so this is the reason for effect on relaxation period. Now you will be recording it with software. Okay? Let us go to theory first. What is written? Effect of temperature on simple muscle twitch. Okay? Overview.
The changes in temperature of
ringer
ringer
solution
solution
causes
causes
the
the change in muscle contraction. With the change in temperature, there is a change in amplitude and duration of different periods of contraction.
That is latent period
Relaxation
Ah.
period. The changes are mainly due to the change in rate of conduction, velocity in the nerve, enzymatic and chemical activation of muscles, and a change in viscosity of the muscles.
Everything is explained? Okay. Then what are the requirement? Nerve muscle preparation is a assembly. You require cold ringer solution that is having 10 degrees centigrade. Then you require warm ringer solution that is 40 degrees centigrade and a chemograph recording device. Okay. What is the procedure?
Dissect the frog and make ready nerve muscle preparation. Second, mount the nerve muscle preparation for recording of simple muscle curve. Third, record a simple muscle curve on the revolving drum with the ringer solution in the muscle trough at room temperature. Fourth, replace the ringer solution with the warm ringer solution and wait for 1 to 3 minutes to allow the muscle to warm up. Fifth, using the same baseline, same point of stimulation and same strength of stimulus, record the effect of warm ringer on a simple muscle curve.
Then
Seventh, pour cold ringer solution to muscle trough and wait for 2 to 3 minutes to allow the muscle to cool. 8. Record the effect of the cold ringer solution. 9th, record the graphical observation in a tabular form.
Okay, come here. Everybody listen to her. How we have to, what is the procedure? Tell them. Under the nerves, then
we will record a simple muscle curve on the revolving drum.
so first you have to give the stimulus, then you record a simple muscle curve at room temperature.
With the ringer solution.
With the ringer that is having normal temperature. Then
we will replace the ringer solution with the warm ringer solution. And we will wait for 1 to 3 minutes. And to allow the muscle to warm up. We will first replace the ringer solution with the warm ringer solution.
Earlier it was a normal ringer. Now I am putting
warm
ringer solution to increase the temperature of the muscle and the nerve.
And we will wait for 1 to 3 minutes to allow the muscle to.
This reaction has to be taken place now. Yes. So that's why some time has to be given. Then
we will use the same baseline. At same point of stimulation and same strength of stimulus, and we record the effect of warm ringer.
Fine. Thereafter,
then again normal ringer solution, then cold ringer solution.
Then again you repeat this experiment, then the third graph you will get. Okay? Fine. Now let us do the experiment with normal ringer. So you just start, record. Okay? So done. Get a photo of this. So this is with normal ringer. Now you change it hot. Okay. See, amplitude increased.
Maximum time of contraction is increased.
Latent period shortened. Contraction period shortened. Relaxation period shortened, but amplitude increased. Okay, now you change cold. See, all the time, latent period, contraction period, relaxation increased. Okay, height also decreased. That is, rate of contraction slowed down. So these are the things recorded. From here you have to take the timing, calculate the timing. Now, observation table. What are there in the observation table? With warm, with cold. Amplitude, whether it has increased or decreased. Upward arrow or down arrow. From the observation, you just make comment, or here you will write upward arrow or downward arrow. So what arrow will be there? Upward arrow. And here
Downward.
Here, rate of contraction.
Increase. So
Decrease.
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 Rate of contraction.
Rate of contraction.
It is the rate of.
Increase.
Contraction. Here,
Rate of contraction is increased.
decreased. Here, latent period.
Decrease.
Decreased. Here, decreased means faster. Here, increased. And here, contraction period.
Decrease.
Decreased. Here, increased. Relaxation period.
Decrease. Increase.
Increased. Okay. Then you have to interpret. Okay.
Rate of contraction.
Any doubt? You are having doubt?
So rate of contraction.
Rate of contraction.
Rate of contraction. I said how you will calculate it.
So calculation increase.
For this, you have to you require the distance. How will measure using in millimeter or centimeter? Using the scale. And you know the time. This is the time for taken for contraction. And how much contraction is made? This much distance. So if you divide the distance with the time, then it will be getting a value which will be this millimeter or this centimeter per second. That is the rate of contraction.
The maximum height of contraction.
Divided by the contraction period. Contraction period. Okay. So this is observation will be made, and what is the result? And I'll tell you this result.